Hello, welcome to everyone. Today we are going to discuss the topic of multiple access and its techniques for wireless communication. The multiple access schemes are used to allow many mobile users to share simultaneously a finite amount of radio spectrum. In general, the multiple access is the ability of a large number of earth stations that simultaneously interconnect to exchange voice, data, teletype, facsimile, and television links through satellite. The basic problem of this multiple access is how the earth station to share a satellite in a way that optimizes the satellite capacity, adaptability to multimedia traffic, spectrum utilization, and cost. The satellite power, user acceptability, interconnectivity, and flexibility. These are the main optimization techniques in multiple access. And there are three basic techniques in multiple access, that is FDMA, TDMA, and CDMA. These are the main classifications of multiple access. That is FDMA, the frequency has been divided for each user, and second one will be the TDMA, time division multiple access. Time has been, each time slot is given to each user, and a third one CDMA, each code is separately given to each user. The next, why and what, we are going with multiple access techniques. The radio frequency is a shared medium. The multiple users are using the same spectrum. As the spectrum is limited, so the sharing is required to increase the capacity of a cell or over a geographical area by allowing the available bandwidth to be used at the same time by different users. The multiple access techniques are used to allow a large number of mobile users to share the allocated spectrum in the most efficient manner. The duplexing technique of a multiple access system is usually described along with a particular multiple access scheme. The FDD is an important technique in which it is used to power the voice and data services. The two band of frequencies for every user will be given, that is forward band and reverse band. Duplexing is must. The frequency separation between forward band and reverse band is constant. The next we are going to discuss about time division duplexing. It is used for forward and reverse link. The TDD, Dana frequency, is used to separate the transmitter and the reception of signals. Thus, single frequency is assigned to a user for both directions. TDD provides quasi-simultaneous bidirectional flow of information. Now we will see FDMA, one phone circuit per channel, and the idle time causes wasting of resources simultaneously and continuously transmitting. Different users can use the same frequency in the same cell, except that they must not transmit at different times. If an FDMA channel is not in use, then it sits idle and it cannot be used by other users to increase share capacity. The next we are going to see about time division multiple access. It has different time slots, one user per slot. It uses buffer and burst method. It is a non-continuous transmission, and digital modulation has been implemented in order to transmit digital data. In TDMA, the entire bandwidth is available to the user but only for a finite period of time. The TDMA requires careful time synchronization since users share the bandwidth in the frequency domain. The TDMA uses different time slots for transmission and reception. As the TDMA shares a single carrier frequency with several users, where each user makes use of non-overlapping time slots. The data transmission in TDMA is not continuous but it occurs in bursts. The result in low battery consumption since the subscriber transmitter can be turned off when not in use. The TDMA uses different time slots for transmission and reception, thus duplexes are not required. The TDMA transmission is divided into frames which contain few time slots. The number of time slots is depending on standard. In TDMA, the duration of frame is 4 microseconds for 6 time slots. In GSM, the duration of frame is 4.615 millisecond for 8 time slots. The central frequencies of the slots are positioned for every 200 kHz. This diagram shows one TDMA frame. It has a preamble, information message, and followed by the trial bits. One information message has different time slots, and each time slot has a trial bits, synchronization bits, information data, and the God bits. The next, space division multiple access. It controls the radiated energy for each user in space. It uses spot beam antennas. Nowadays, it is changed into isotropic antenna, and the base station tracks user when moving from one place to another place. It covers the areas with the same frequency. It uses TDMA or CDMA systems. In space division multiple access for primitive applications, the sectorized antennas are used. In future, the adaptive antennas are going to be replaced simultaneously to steer energy in the direction of many users. Most probably, they will use isotropic antennas. The reason why we are going with space division multiple access schemes. It uses adaptive antennas to promise the mitigate in reverse link problems, the limiting a case of infinitesimal beam width and limiting the case of infinitely the fast track ability. Hence, the channel that is free from interference and the users can communicate at same time using same channels. We will see the spread spectrum multiple access in which it is classified into frequency hopping multiple access and code division multiple access, hybrid spread spectrum multiple access. In FHMA, it again classified into slow frequency and fast frequency hopping multiple access, and CDMA further we are going to see hybrid multiple accessing techniques. In spread spectrum, this information data is given to the channel encoder. Then the modulation process is carried out with the help of a pseudo noise signal, and then the signal is transmitted with the help of a channel. The same signal will be received at the demodulator, and then it is decoded along with the PN sequence signal in order to get the original transmitted data. The next, we are going to see the code division multiple access scheme. It is the one in which it allows many users to share the same bandwidth. For example, 3G, and then it is having a standard that is called as IS95, interim standard 95. Then the basic principle of CDMA says that each user is assigned a unique spreading code. This spreading code may be Walsh code, or another code will be pseudo noise code that will be obtained by the feedback shift registers. It is nothing but the error sequence that will be obtained by the feedback shift registers. The concept of CDMA says that sharing the same bandwidth for different users, and the separate code is given to each user. Hence, the interference will be minimum and hence increasing the overall efficiency in CDMA systems. This is the CDMA evolution paths for 2G, 2.5G, and as well as 3G. We are transferring nearly 2 Mbps per second, but at present we are reaching at 5G and the data bits transferring will be in gigabits. This is the general architecture of CDMA, in which it has a mobile station MS, BSS, base station subsystem, and base station supporting center BSC, and as well as network subsystem that will be governed by MSC, mobile switching center, and it has a location registers, home location register, verification location register, and equipment identity registers. Along with this, it has authentication center AUC, and then it is connected to the PSTN public switched telephone network or ISDN. Hence, the CDMA is superior to FDMA and TDMA. Therefore, CDMA technique becomes more important in radio communication system, and as well as the CDMA based spread spectrum technique, which has been used in military fields. Thank you.